In this lesson, we'll talk about change and the havoc that it wreaks on brittle software systems. Then I'm going to focus on the patterns and practices that developers have come up with through the years to build software that's resilient to change. Now, you can't avoid change, and you can't necessarily plan ahead for every change, but by applying good architectural patterns, you can mitigate its negative effect on the systems that you design. In the previous lesson, I said that we often compare software architecture to the architecture of physical buildings. But as we noted, that's not always a fair comparison. After all, changing the structure of a physical building is very difficult. Not necessarily impossible, it's just very time-consuming, labor-intensive, and therefore very expensive. Now, while it's true that code is relatively easy to modify when compared to tangible things in the real world, that doesn't mean that it's just plain simple to make changes all over the place either. Making changes to an existing software architecture can be extremely challenging. And yet, business processes, business rules, business workflows, and so on must change to adapt to new problems, new opportunities, and new pain points within the organization. So the software intended to support those processes, rules, and workflows must be adapted to support the new needs of the organization. Since larger software development projects can take months or even years, sometimes the business needs to adjust a rule or process which adversely affects the software being built to support the rule or process during the course of the development lifecycle. The software development team is constantly playing catch-up to support the latest machinations of the business users, and that's always a challenge. But even if the business requirements don't change per se, there's always the architect or the software development team's perception of the requirements during the design and development phase of the project lifecycle. We already noted that, given limited time, it's impossible to fully understand, to fully comprehend the full scope of the business need and the solution. We come to a fuller understanding over time, and we evolve our designs in that manner. So there's bound to be missteps and erroneous conclusions made earlier in the project that must be corrected later in the project. This is a form of change that we have to acknowledge. Even if the business stands still, we're going to have to fix our own misunderstandings of the system as we go along. And finally, we all know technology changes frequently, as well as sometimes there's a financial reason why we may want to change an existing system to leverage a new technology. For example, we have a website and we want to allow it to be used on mobile phones. Or we have an aging server farm and we need to decide whether we're going to lease new servers or deploy our application to the cloud, to Azure, and only pay for what we actually use and what we actually need. In order to take advantage of those opportunities or cost-saving moves, we need to modify existing systems. So to sum up, change is one of the largest challenges to software development teams, namely changes in business requirements, changes in the understanding of the problem domain, and changes in technology. And so the architecture of the software system must take this into account, otherwise it'll be rendered useless very quickly. As we noted in the previous lesson, there's absolutely no way to know upfront the entire scope of the project, and certainly no way to foresee every change request that'll be imposed on our software. So, our software architecture, or rather, our architectural decisions, must be resilient to change. What does resilient to change actually mean? It simply means that, ideally, our architectural decisions must be able to absorb change, to recognize those areas where changes may happen in the system, and plan to allow for potentially different implementations in the future. And because you're familiar with the business problem, you'll probably be able to anticipate some of the changes. For example, if you're working in an e-commerce system, you're going to know that there will be promotional changes over time. You may know that there will be tax changes over time and things of that nature. However, nobody can anticipate every single change, and so we rely on well-worn, well-known architectural patterns and practices. More on those in just a moment. Another way to describe resilient to change is flexibility. When a software system is resilient to change, it's often is resistant to change rather, it's often referred to as brittle, resistant to change. Okay, what makes software brittle and what makes software resilient to change? One of the biggest culprits is coupling. In software development parlance, coupling is the degree of reliance or dependence that one module, whether it be a layer or a class or what have you, has on a second or subsequent module. All right? Coupling can happen at a very low level where one class depends too much on the implementation of another class. Perhaps an order class depends on how a shipping class is implemented. And changing anything about the shipping class could potentially break the order class. It can also happen at a very high level in your system, where one module, like a whole component, an assembly, a DLL, depends on another module in such a way that you can never make a change to one without breaking the other. Now, some coupling is acceptable and some is not. I'll talk about that a little bit later. Generally, if you have coupling where a change needs to be implemented, you have a problem waiting to happen. I'm speaking in very generic terms here. Let's get a bit more concrete. One way to reduce coupling and take your first steps towards architecting software that's resilient to change is to introduce common high-level principles and patterns into your architectural decisions. So what you see on screen right now is this diagram. It is a common layered architectural pattern. It's often used in enterprise software development projects. It's called the layered architecture. It separates major concerns of the application, which is a phrase that you're going to hear often throughout this series. Now, by itself, it's not going to solve the problem of change. And many have created layered architectures, but have coupled them together in such a way that you're no better off than when we started. However, a layered architecture is a good first step. More about this in a moment. But as you'll see, resiliency to change is the motivation behind most of the high-level architectural principles and patterns that we're going to come across. Now, we've already had an early look at the layered pattern. We'll come back to this in the next lesson. Let's focus on a couple of the most popular high-level design principles. For example, separation of concerns. The layered architectural pattern is an embodiment of the separation of concerns principle. A concern is a generic term. You can bend it and twist it to mean whatever you want to. Now, from a high-level architectural perspective, I define a concern as a logical grouping of responsibilities. I'll give a more proper definition of a responsibility a little bit later, at least according to Robert Martin. We'll talk about that in just a second. But for now, think of a simple console window application that we've built so far up to this point, maybe in the fundamental series. You can think of the various responsibilities that went on even in our most simple applications. Something must be delegated the responsibility to retrieve user input and validate it. Something must be delegated the responsibility to display the results of an operation to the end user. Something must be delegated the responsibility to retrieve or store data into a file or database. Something must be delegated the responsibility to perform a calculation, a decision based on input, or push a workflow forward. So, truth be told, up until now in the console window applications that we created in the C# Fundamental series, in many cases, we mixed these concerns together into the same methods that we wrote, most of the time in the sub-main of the console window. We would write presentation code like console.writeLine statements right next to persistence logic, where we save data into a file or into a database, and it worked fine because we created simple examples. As the requirements of the software become more complicated, this is not sustainable and it leads to a brittle system. When we isolate each concern into a component or a layer or whatever you want to call it, we can more easily replace the original implementation of that concern or layer with a new implementation to address that concern. So for example, the motivation for separating the presentation responsibility from the domain logic responsibility, in other words, any logic that enforces business rules or validation on the data, is because you want to change the user interface. Today you want to build a website, sure, but tomorrow you might want to build a native mobile application. Now, are you going to rewrite the entire application just because you want to change the presentation? No. By keeping the responsibilities separate, you can easily replace a software layer that implements a responsibility with a new layer using a different technology. For example, iOS, WinRT, WPF, ASP.NET MVC, ASP.NET Web Forms, whatever the case might be. The same is true with separating the domain logic responsibility from the data persistence responsibility. Today you use a local instance of SQL Server for development. Tomorrow you want to use a distributed version of SQL Server in your local enterprise. The day after that, you might want to use Azure Tables and Blobs. Are you going to rewrite the entire application just because you want to change the underlying persistence technology? Absolutely not. Now, in order to make all this work, you have to have well-defined interfaces between the layers, and you have to make sure that one layer isn't tightly coupled with another layer. And we'll get to all that stuff later. It's fun. But in a nutshell, you separate concerns in a system to make it more modular. You make it modular so that you can focus on a given concern in isolation. That gives you some added benefits. For example, it's great for team development so that different teams and groups or individuals can be working on different layers all at the same time. It's great for unit testing because you've isolated each area of code and you're able to unit test it individually. But you also get the benefit of potentially replacing entire implementations. And there's another benefit if you do it right, but that's better expressed by a complementary principle called the single responsibility principle. This principle is motivated by change as well. But this has to do with addressing change inside of a given module or layer, or even at a granular level, a class. Now, most of the documentation and examples apply the single responsibility principle, or SRP, you might see it, to classes specifically. However, it's a good higher level principle to apply to your architecture as well when we think in terms of layers. SRP, single responsibility principle, says that each class or module or layer should have a single responsibility, and that responsibility should be entirely encapsulated by the class, module, or layer. Now, all of its services, in other words, its purpose, its activities, should be narrowly aligned with that single responsibility in the system. Now, Robert Martin defines a responsibility as a reason to change and concludes that a class or module should have one and only one reason to change. For example, again, this is going to be a very granular example, but you can apply this at various levels. He talks about a module in the system that compiles and prints a report. The module can be changed for one of two reasons. First, the content of the report can change. And second, the format of the report can be changed. These two things change for very different causes. One is substantive, we're changing the content. The other is cosmetic, we're changing the format. All right, so that would be two reasons to divide or to split up and to give those two responsibilities to do two different modules or layers or classes or whatever the case might be in your system. The single responsibility principle says that these two aspects of the problem are really two separate responsibilities and you should separate them into their own classes or modules. It would be a bad design to couple together two things that change for different reasons at different times. So the SRP, single responsibility principle, helps you delegate responsibilities in such a way that you reduce the coupling in your code. And we already said that coupling is one of the major culprits in making your code brittle. Moving on, let's talk about DRY or dry or don't repeat yourself principle. Change is the motivation behind the advice of don't repeat yourself. If you sprinkle the implementation of a given responsibility across many different methods and classes or whatever, then you need to make changes in multiple places whenever a business rule or a process or a workflow changes, or if you have a bug in your code. Chances are you're going to miss something, and so to make your applications impervious to change, you should seek to delegate a discrete responsibility to a single method or class or component or layer or whatever the case might be. You see how many of these principles are saying basically the same sorts of things just in different ways or addressing different sides of the same coin? They all deal with the topic of managing or mitigating change in a software system. Now, many principles and patterns were established as a means of managing the impact of change on software systems, but many software development practices were established for the exact same reason. Recall what we learned in the previous lesson with regards to big design upfront, or BDUF, what I wanted to call BUFD, B-U-F-D, but nobody asked me. At its core, BDUF has to do with managing change, in this case, during the design phase of a project. The idea is that since change is likely during the course of a development effort, spending too much time upfront on design is counterproductive. You're wasting time on something that's likely to change anyway. No matter what, you're trying to hit a moving target. Instead, do a moderate amount of design at a high level, institute software development practices that help you absorb change, things like test-driven design or at the very least unit testing, and then work iteratively to solve the problem. I'm going to create a short series on agile software development using Team Foundation services that'll help you see how all this comes together in a real scenario later on. All right, so let's wrap this up. The big takeaways from this lesson are change. Change in business rules, change in our understanding of the problem, or in the software the organization wants to leverage. Whatever. Change will impact the software that you're designing today. If you want the software to have the longest life possible, then you need to think about the effects of change on the system, because it'll be inevitable, and some types of changes you can anticipate and some you can't. Secondly, to mitigate change, apply time-tested principles throughout the entire life cycle. We'll focus on the principle of separation of concerns and the single responsibility principle, which tell us to mitigate the impact of change to our software. We'll keep things that change for the same reasons separating our own modules, and we'll talk about it throughout this series. So we'll take that idea and we're going to use it in the next lesson as we talk more about layered architectural patterns, which is the most common architectural pattern of all. So we'll talk to you about that in the next lesson. Thank you.